All right, so let's talk about the adapter pattern. Oftentimes, when we're building applications, typically we use lots of different libraries. Oftentimes, off-the-shelf libraries that we either purchase or open source, and oftentimes, they do similar things or they kind of complement each other, and we particularly have our own particular data model, the way we represent data. And these libraries oftentimes have their own way of representing their own internal models. So oftentimes we want to use these libraries or even combine them or integrate them, but it's somewhat challenging because the way they represent the data model is different than the way we represent the model, right? And oftentimes we need to integrate them nevertheless. So the adapter pattern, of which there are two versions, two styles of the adapter pattern, allows us to do those kinds of things, right? Do the transitioning between libraries or APIs that are almost the same. It's very similar. They almost apply the same kind of use cases, but their data representations might be different, and so we need to, like the name suggests, adapt, right, or make this interaction go smoothly. First, we'll look at two trivial examples where it's easy to do the transition between two different implementations, and then we'll point out cases where it's not quite as simple, right? And how do you deal with those edge cases that it's almost adaptable but not quite, right? They're not everything is adaptable, and we'll look at cases where it just makes no sense to do the adapting, right? So we'll look at first a really simple example on where adaptation makes sense. We'll look at edge cases where it's not quite implementable, and then we'll look at places that it just makes no sense to do the adaptation. Okay. Right. So it's very common that when we start building and working on an application, we usually don't start from scratch, right? We either jump in the middle of a project where a team has already been working for months, years perhaps, and we don't get the pleasure of starting something from scratch. We all love to work on something from scratch. We hate maintaining somebody else's code, but nevertheless, it's very common that indeed is what happens, right? You jump in maintaining someone else's code. Yes. It's oftentimes your code will outlive you, in a project. Right? Whatever you code will be there long after you're gone and moved on to some other project, some other company, and it will be somebody else's responsibility to maintain your code. Right? So oftentimes we strive the importance of coding for the team, coding for someone else, because someone else is going to have to maintain your code, right, at some point. So however you can make it easier for others to maintain your code, the better. So oftentimes you're using somebody else's library, and we see that perhaps this library does more or less what you want it to do, but then this other library does half of the other rest that this other library doesn't, and oftentimes you want to merge them and say, "Ooh, wouldn't it be nice if this were just one single library? Could I abstract one perhaps in terms of the other?" Right, and perhaps abstract it in the data model that I want, right? And so we like to be able to integrate these things that are somewhat similar but not quite, right? So we'll look at two simple libraries. Both of them deal with set operations, like being able to add or remove or find things in a set. One of them deals with individual elements, right? Being able to add an integer to a set or remove an integer from a set, right? Or find whether that particular integer is in a set, right? So one of them will focus on operations, set operations on individual elements, right? Then we'll look at another implementation, another interface that deals with also sets, but not at the individual elements, right? Instead, it deals with set operations, like maybe merging two sets, right? Or doing set operations like differences or ands and ors and many other operations that are set operations, but not individual elements. Make sense? Right? And what what we're going to try and convince you is that, ooh, maybe you could write one in terms of the other, right? Depending on what code you're writing, or depending on the code that you might already have, right, that has already been written by someone else, it says, ooh, this code expects a class of this type, right? But I have this library that works in some other data model for this other data set. So could I possibly, perhaps, write one in terms of the other, right? Maybe through inheritance, maybe through composition, right? And perhaps do somewhat of a facade where one method is written in terms of the other. Okay, so we'll look at this first interface, a kind of like a graph library that allows you to deal with individual integers, right? Being able to add integers, remove integers from a set. Okay, so let's take a look at the interface. Right, it's pretty simple, straightforward. It's an interface that allows you to add a new integer, remove an integer, ask whether this particular integer is in that set, and also allows you to iterate over this integer. That iteration, later on, will come back to bite us, right? On it'll be, although we'll be able to implement them, right? Later on, we'll see where how far we can take it, right? And we'll see that there is a limit on how far you can take this idea of the adapter, all right? Nevertheless, we'll look at this and then look at another interface that also deals with sets, right? But not at the individual level of individual integers, but instead as a set, as a data type. Okay. So yeah, so this interface, and perhaps someone went on and implemented this interface, right, with a constructor, and internally they might have used Java sets or maps or hash tables or however they wanted to implement the set. All these methods would be obviously implemented. The actual implementation doesn't really matter. We really care about the interface, right? The methods, the signature of the methods. So we might have a no argument constructor, a default constructor that initializes all the private variables ready to implement all these, right? And the implementation, again, it's irrelevant how it's implemented. So here's another one. Here's the other interface, right? Perhaps this is a different library from a different vendor, right? With its own package, with its own whatever, right? We paid for both of them, or maybe both of them were open source, and we downloaded them. And half of my code somewhere in the bowels of my source code, it's using one implementation, and somewhere else in another part of the code, it's using some other library. Yes? And this brand new feature came up that I need to implement, and ooh, right? Wouldn't it be great? I find myself that my code wants one implementation, one interface, right? It's expecting to see a particular object of a particular data type, but it'd be great if I could reuse the implementation from that other library, but it implements some other interface. So they're not compatible. Right? I cannot pass it. Right? I cannot pass the object that I have, which is the wrong type. I can't pass it to the other. Right? So I have two objects or two implementations. One of two different data types. This one is int set2. And notice that we have union with, right? And notice that this interface doesn't deal with individual integers. Instead, it deals with with sets, right? Whole accumulation of a whole bunch of integers, right? So I can calculate the union. I can create the union with some other set, which basically adds all the other integers from that other set into this set, right? We have a difference from, right? So it calculates what are the elements that are not in any one of those sets, right? So the difference between the two, or asks whether this particular set that I'm in, the current instance, is it already included in a bigger set, right? Am I a subset of a bigger set, right? Again, these are all very common operations on set theory. We could also ask it to represent it as a list for convenience purposes. Maybe we can iterate over the set in an ordered list. So yeah, so we have these two interfaces. They're very similar, right? We could perhaps imagine that the union with is basically just rewriting, or we could perhaps use the implementation of the add, right? You know, to implement the union, basically you just have to iterate over the other elements as a list and just call add multiple times, right? We could extrapolate the fact that perhaps we could write one in terms of the other, right? That they're basically the same thing, but in perhaps a different level of abstraction. Okay. So yeah, so this is a different library, the probability library, the prob library, and the other one is the graph library. Two different libraries, two different vendors, two different packages. They're not compatible, right? These two interfaces are not compatible. Also, this second interface has an impl, right? That implements this interface. It doesn't have a constructor. Instead, it has a couple of factory patterns, factory methods that return an instance of this interface. One which is empty, which has no elements, and the other ones that has this individual integer, right? It's a set that has this integer, right? These are just convenience constructors, right? But not really constructors. They build or instantiate these instances of these impulse, right? So that we can then initialize them using these factory, right, as opposed to constructors. Okay. Right. This will come in handy later on when we were implementing one in terms of the other. All right. So the question is, I have code, right, in different parts of my big project and somebody asked me to implement some new feature, and I'm writing it, and it says, ooh, this part of the code expects an int set1, right? But it would be very convenient, right, in some other part of the code that gives me an int set2. It'd be very convenient if these two, perhaps I could pass one of one type to the other of the other type, right? But I can't because they're not compatible, right? So the adapter pattern to the rescue, right? We'll see how perhaps what we could do is implement a class that does a translation between one and the other, right? And have this implement the interface that it's expecting, right? I'm expecting int set1, so I'm going to implement that interface, but I'm going to inherit from the implementation of the other. Right? And what I'll do is just, since I'm implementing this interface, well, I need to implement all the methods in that interface, but I don't want to have to re-implement it. What I'll do is that I'll inherit from the other implementation, and I'll just forward my implementation internally of one interface will just be written in terms of the methods of the other implementation. All right? All right? So we'll see how this we can do this. So yes, we can. We can certainly use these, right? Using the class adapter.